So, as I told you this morning, I'm working at AgroCampus West in the Carvage team for quality and resistance to pest and disease in vegetable. And today I would like to answer to this question, is how strain of carrot restricted to Alternaria Dauci? So this work was done with a lot of people from Carvage, but also from another team of the IRHS, which is the fungicide team, and also by with the collaboration of Villemorin. And this work was mainly done by a PhD student, which is Cora Buedo. So probably, as you know, leaf blight is due to a fungus, which is Alternaria Dauci. So at the beginning, the lesions are quite yellow and they are evolving brown lesion. And in case of severe damage, you may have totally leaf blight, as you can see on the right. So all the organs may be affected, such as the leaf, the petal, and also the umbels. Alternaria leaf blight is the most destructive foliar disease on carrots because the fungus is really present worldwide in all carrot production areas, and it may attack the plant at any stage of development. And numerous sources of disease in inoculum were reported, such as the infected seeds, the carrot debris, volunteer carrot plants, and also white carrots. And of course, the symptom may reduce the leaf photosynthetic activity, and in the same time, you may have a reduction in the harvesting efficiency because the leaf may be completely blight. Alternaria Dauci is also a problem in seed production because the fungus is transmitted by the seeds. So actually, at this time, the main option to reduce the disease is to use a chemical, but sometimes it's not always efficient. It's quite expensive, and you may have a problem for the environment and also for the human health. So the best way is to combine with cultural practice and also genetic resistant variety, partial resistant variety. And of course, if you can combine many, oh, there's a problem. I don't know why it should appear. It's not appearing, so okay. If you combine different strategy, of course, the more you will combine, the more efficient you will be. I'm sorry for that. And at this time, we have information about the plant, and we need to have information also about the aggressor to be more efficient. And this information are related to pathogenicity. So the pathogenicity may be the aggressiveness, so I won't talk about aggressiveness today, and also may have information about the host range to have this integrated disease strategy. So what do we know about the Alternaria Dauci host range? We know that Alternaria Dauci was reported to be virulent on cultivated APC such as celery, coriander, parsnip, and parsley, but also on wild APC. So you may say, okay, we have the answer to your question. You don't need to go on your presentation, but yes, I will go because in fact it's not so easy to answer to this question. Some studies have shown that plots of parsley, fennel, and celery were free of disease, while there were really near to plots of carrots which were infected with the pathogens. So Alternaria Dauci host range is very controversial, and of course we need to do more studies on this question. So this is why we did this experimentation in our greenhouse, or in controlled condition. We inoculate 17 species belonging to 6 botanical families, different botanical families. So we inoculated cultivated APC, you have here on the left, and such as dill, carrot, celery, celeriac, etc. You show the list. You have the list, and also we inoculated wild docus species and other botanical families such as Brassicaceae, Poaceae, Liliaceae, etc. And the inoculation was done at 6 weeks after the sowing with 2 isolates, Frey 1 and Frey 17, which have almost the same level of aggressiveness. And after that, we rate 5 times the disease severity, so the symptom on a 0 to 9 scale. 0 stands for no symptom, and 9 stands for severe defoliation. And we also take into account the diameter of the necrotic lesion. After that, we realize isolation from symptom. We put on Petri dishes, and we did some morphological characterization of the fungus. In the same time, we realize in vitro sporulation on detached leaf. You can see here the picture of the sporulation. And after this, we realize molecular characterization. So in 2 steps, the first step on the left to characterize the species level, so with specific PCR primer. And on the right, we did an isolate identification with also specific marker, microsatellite marker. And what are the results? I'm sorry for the color. It should not be exactly like that. It's better on this, yeah. So what are the main results on the cultivated apiaceae? So all the cultivated apiaceae, on all the species there was symptom. So the disease index was quite important on carotte, between 5 to 7, but also on deals, and there were intermediate disease index for the other species. And there were 2 groups. The first group with carotte, fennel, and deals, with evolution of the lesion diameter, and for the other, there were no evolution of the diameter of the lesion. For all the species, we observed sporulation, and quite important, on the detached leaf. And the identification of the isolate was confirmed with all the tools I presented before, so morphological and molecular too. Yeah. No? Okay. On the wild apiaceae, almost same result. All the species had symptoms, and quite important, between 5 to around 8. And there were also, in this case, there were evolution of the lesion on all the species, and also sporulation on all the species for all the species. And again, we confirmed the presence of the fungus in the plant with the molecular identification and morphological identification. So here you have some picture with some symptom on the different locus. And on the third group, the result on the non-apiaceae species, so there were, there were in fact two groups. So you have species like cress, corn salad, radish, and tomato, which present a disease index which was lower than the one obtained on carotte and wild species, but quite important, you have some symptom on the picture. And in that case, there were sporulation on all the leaves. And there were 2 species, so where there were no symptoms, and of course no sporulation. Also, it was for sweet corn and for leek. So here, just to show you a picture of a molecular profile. So in fact, each lane is corresponding to a plant sample, and a band, in fact, is a way to confirm that the fungus is, multiplied in the plant, and was identified in the plant and multiplied in the plant. So there were identification, as I told you, in all the species except leek and sweet corn of the pathogen. So to resume all this result, we can say that there were moderate to high disease index on all the plant. There were on almost all the plant. There were lesion increasing or not, so 2 groups, and there were sporulation on a detached leaf. So you can see here some picture of a sporulation on the leaf of carrot or radish. And important things, we obtained the same result with the 2 isolates. And the symptoms were present on all the dicotyledon, but there were no symptoms on the monocotyledon, as I told you, on leek and sweet corn. So with that result, we can realize 4 groups, depending on the disease index and also depending on the expanding or not lesions. So the first group corresponds to the carrot, the dill, the fennel, and also the Y-Dauci, so with high disease index, but with expanding lesion. And the group 2 and the group 3 are species with, in the first case, high disease index, in the second case, low disease index, but in the group 2 and 3, there were non-expanding lesions. So here you have species such as chavai, coriander, celery, parsnip, etc. And the group 4 is a group, there were no symptoms at all, so here it's sweet corn, it's not corn, it's sweet corn and leek. So we may say that for the first group we had the susceptible host, the main host, and so it's not a problem for the fungus to develop in the plant, and after that it's more difficult in a tolerant host, but you can add a development, and at the end you have the non-species, the non-hot species, so with a total resistance. So all these results are important, of course, for producer to try to reduce the disease incidence in the field. We can use this key, in fact, to, I think the most important is to choose the previous cropping, of course. The better is to choose a plant species which is non-host for the Alternaria Dauci, so it's better to choose plants in the group 4. And if you take the groups 3 and 2, you may have, of course, some problem for the next carotte. And the group 1, there is a very high, the risk factor is very high to have problem in your carrot crop. Of course, this result is also important for taking into account for the spatial organization sowing of crops. Because you need to control the pathogen in the field, but also in the surrounding field. So you may use this key for doing the same, to have the same thinking about how to choose the crop. And I think this result may also be important for two different things. Of course, we saw that the Y-Dauci are very susceptible, so we need to inspect regularly the carotte field ages. And it could be used for maybe improving the isolation distance in carrot seed production by taking into account this result. And maybe also in the future, it's not my job, but I think it could be very interesting to improve the predictive model by taking into account this information on the choice of previous cropping and the choice of crops in the surrounding fields. So, in conclusion, I say that Alternaria Dauci is a polyphagious species, and of course there is still remaining question. So I list only 3, but I think there is a lot of. And we test only 2 isolates. I say only 2, but it was quite important. But so it could be interesting to test and to see if we have the same result with more or less aggressive isolates. And this result were obtained in controlled conditions. So do we have the same? We will have the same result in field condition. We don't know. So also here could be interesting to add the study of the dispersion of Alternaria Dauci in the space and between during the year, and to see if there is. If we obtain the same results. And also the last question is, can we consider the non-carotte species showing Alternaria Dauci lesion as an inoculum reservoir? Because here we were with a very good condition for the fungus to develop, so maybe the fungal sporulation would not be observed in the field. So all of this need to be confirmed, sorry. And so here I would like to thank, here you have only the picture of the actual carvage team. And so I would like to thank all the people who realized this study. But there were also, as I told you, people from FENGISEM, and especially Pascal Poupard. And also, of course, Cora Buedo, which was the PhD student who realized most of this work. So, and thank you for your attention.
How many years are necessary with non-host crop to avoid or to limit development in carrot? If there are no contamination, aerial contamination? Only 1 year?
No. I think it's almost 5 years.
5 years?
Yeah. So it's better to have a lot of way to prevent the disease.
5 years with non-host or 5 years with non-host or tolerant host?
I don't know. I can exactly answer to that. We didn't do that. So yes, good question. Yeah, I have not the good answer. I think I will say almost the same year, but I can tell exactly. Yeah.